another regional. This time it's Chennai regional. The contest has started around 30 minutes ago, and right now we have ACs on four different problems. We will probably briefly discuss the problems. And before we get started, can anyone know if audio, video, and everything is fine? And yeah, this time we will have rank list. So probably you can find this problem statement and rank list on this page we have. And no, we will probably not have a mirror here. No, there is no mirror here. And like, do let me know which is your favorite team. And yes, this contest is rated. Do let me know which is your favorite team and probably teams you might be routing for. So I think probably let's start with shout out to the teams who have solved at who were the first solved for each of the problems. So like the easiest problem team so far is cascading operations. And first AC over here was by team. Okay, we will have to look at rank list. I think we have a public rank list with us. Okay, looks like username is not present here. I think we can probably manage using this link here. Okay, first in AC was by team ICPC Maxim from NIG Silicher. They were the first team to get an AC in the contest and it was on problem cascading operations. The second agent's problem so far seems balanced subsequence. And checking the first AC on this one as well. Okay. This was by team 69 by 70 test cases passed from Manipal Institute of Technology, Manipal. They were the first team to get an AC on balance subsequence. Third highest solved problem right now is good sequence, which has 43 ACs so far. And first team to get AC on this one was Team the Blasters from IIT Madras. And like the fourth problem as distinct problem which has been solved so far is ABC stem. And this one was solved by 001. I think on the spectrum from IIT Delhi. And like rank list right now looks similar to what we had in Kanpur, Amritapuri regionals. At first, we have CMI with team I said from CMI, which has solved four problems right now. They were the winners of Amritapuri regionals. Then we have on the spectrum from IIT Delhi. They were the runner-up in the Amritapuri regionals. And the third team we have right now is IIT Bhubaneswar. From IIT Bhubaneswar, Distorted Primes. And then we have multiple teams on 3 ACs so far. The team at rank 4 right now is using namespace ICPC from IIT Kanpur and the Blasters from IIT Madras. Way 2 AC from IIT Gandhinagar. So that's where we stand. Do let me know your favorite team over here today. And that's where we are like so okay, I think probably I can just read out the easiest problem so far. Like the easiest problem right now is cascading operation. The problem statement says you are given string s of length and consists of lowercase English characters only. It is guaranteed that si is not equal to si plus 1. Basically, none of the consecutive characters are equal here. You must insert a single lowercase character somewhere into the string, and afterwards the following process happens. While there exists an index I such that si is equal to si plus 1, basically two consecutive integers, such an index I is found, we delete both si and si plus 1 from the string. Also note that it can be shown that at any point of time there will be at max only one such integer here. Please determine if it's possible to choose the character and location appropriately so that the string becomes empty at the end of the process. There are t test cases and one string in each test case, and sum of n is up to 2e5 here. In the examples, for example, we have AB. Here the proposed solution is we insert B in between so that the string becomes ABBA. We will first delete these two characters and we will be left with just A, and then we can delete those two characters to get an empty string. While for the string ABC, you can probably notice that at any point of time, whatever character we add, only one character would be deleted, and it can be proven that the answer will be no here. So, any ideas from people in the chat, like what would be your solution idea on how to solve this problem? And looks like things are now gearing up for ACs on ABC stamp as well. Like the cascading operations had around 100 ACs now. And I think 131 was the count of number of teams that have qualified for it. And right now I'm not sure like what is the number of teams present on site. So that's where we stand today. And I think I will probably read out. Okay, looks like we have one more AC on Howard problem as well. Okay, this AC is by team 004. And this is CMI again. So CMI has now five ACs right now. Like the leaderboard is yet to be updated here. And we have three teams at four ACs and remaining team at three ACs right now. And yeah, like problem statements are pretty interesting today. Okay, looks like we have one more AC on Howard. This is 001. I am assuming yes, 001 is on the spectrum from IIT Delhi. So yeah, looks like potentially we have five faces by the first two teams and then two fours and the remaining threes. Okay, yeah, like this rank list is a bit delayed, but yeah, you can find your favorite team here. And probably let's look at some of the interesting team names here. I shared Distorted Prime using name ICPC, 2 by Touristers, ETHOS, Triple IT Hyderabad, preview only. Yeah. Oh, Nerve. Okay, Nerve is from VJIT Mumbai. Okay, right now looks like they have solved only one problem, but they might be gearing up for the next race right now. Yeah, and yeah, that's where we are. Like, I think probably I will also read out the second problem for today as well. Okay, second easiest problem is balanced subsequences. We define a set of balanced string in the following ways. Empty string and a string with just one opening and closing bracket are known as balanced, where opening appears before. If a string A is balanced, so is A inside opening and closing parenthesis. If A and B are balanced, then so is A plus B. A plus B is the concatenation of strings A plus B, A and B. So these are regular parenthesis sequences we have. And now we have been asked, given a string S, let f of s denotes the longest balanced string, which is the subsequence of s. Note that a subsequence may not need to be continuous. So basically, we have been given some string S to us. We can remove some characters from it, and the remaining part should be a balanced parenthesis here, parenthesis string. And we have to find what is the longest length we can have. And because this might be too easy, so problem setters have decided you are given a string S of length and consists of only these two brackets. Find n values, which is like f of only the first character, first two characters up to and first n characters. Like solve this problem for every prefix. The n is again up to 2e5, 5 here and many test cases here. And here, like probably like the odd palindrome idea for cascading operations looks correct here. And yes, this is in fact correct, not probably. No. Okay, Sren wants to know how to solve problem E. Yeah, so like the odd palindrome idea is correct for the cascading. Like we can probably prove that at any point of time, whenever we delete characters, we delete two characters at a time. So when we start deleting, we should have even number of characters to begin with. And because we are inserting one more character, starting string should have only odd characters there. So if n is even, we can directly print no. If n is odd, then it is potentially possible for us to solve the problem. And now the idea is like, let's say if we insert a character at the first place, then character at the first place should be equal to the character at the last place. No, that's not true actually. Character at the first place should probably be equal to like at any place wherever we are inserting a character, that character should be equal to the nearby character over there. So if we are inserting it before the first character, then it should be equal to the first character. And if we have that case, we will end up with only deleting the first two characters because we know that the third, fourth character will not be equal to begin with. And now, if you try to play around with cases here, you will realize it's always possible to delete an odd length palindrome. The idea is you insert one character at the center, which is equal to the middlemost character, and this definitely works. Like the tricky part would be if we try to prove it the converse. What happens if this is not like basically if it's not a palindrome to begin with? And I think my favorite problem in the set was this one. Where is this? I think arithmetic subarrays would be the one I have. And like good sequence is also a pretty nice problem. And I think probably I will read out the third problem as well. It again says a sequence V of length m is said to be good if the number of indexes I such that Vi is equal to I is at most half. Given a sequence A of length n, you want to find the length of longest good subsequence A. Please find this value if no non-empty good subsequence exists, print 0. And the examples here are if we have only one string, the answer is 0 because half of 1 is 0 here, or 1 0.5, whatever you call it. And in case of 2 1, we can just pick the complete string. Like the maximum frequency each character appears is 1, and we are good. Okay, IIT BHU rank list. IIT for IIT BHU, the team to be Curly is at rank 7 with 3 problems right now. The next team is the team placeholder at rank 38 with 3 solves. And the next team is prefer not to say, which has 3 solves and is at rank 49 right now. Okay, by the way, is anyone watching the cricket match by the way? Or prefer not to say got 8th rank, like they might be then catching up soon. Like right now it's too early to predict anything, but since like few people might be solving on different problems here. And yeah, we have only 5 aces so far. Like any ideas, like any comments, anyone, like which problem might be the remaining teams should be solving here? Like if assuming if you have seen the problem statement we have on our code forces blog, you can find them here. People will solve A, B, C, D, E, F, G, H, I, J, K, L. Why not M? Okay, looks like we have one more AC on odd composition as well, which is team 007. And 007 is the next ICP, next team from IIT Delhi, which is Touristers. So looks like potentially we have two IIT Delhi teams in top three right now. Okay, looks like we have had two tight competition between CMI and IIT Delhi here. I was assuming CMI is better, but looks like they have one penalty here. F and J. Okay, F, the problem statement says easy counting problem. And the statement starts with, did I copy a problem from Kanpur regional and ask you to solve it again? Yes, I did, Suhi. Like problem statement is pretty much the same except probably a few characters changes here. And probably yeah, the order in which the deletions happen as well. Like flavor is similar, but this time this is definitely not an easy problem. So problem setters are trolling by saying easy counting problem this time. Okay, this one is a neat problem. Recursion J problem J is recursion. Recursive define the sequence x1 equal to 1, x2 I is 2 xi plus 1, and x2i plus 1 is 1 by x2i. So it's pretty much for every odd index, the value is just one reverse of the previous value, and for every even index, it's one more than the half value at the half of the character. Next, define yi as the smallest positive integer such that yi by xi is an integer. It can be proven that such an integer always exists. You are given two integer L and R. We have to find sum of all yi from L to R. And since the answer can be large, we should output it modulo given mod. And L and R up to 118 and number of test cases is 24. Well, looks like we have one more AC here, which is team 036. 036 is team IIT Gandhinagar way to AC here. Okay, looks like we have total 108 teams. So it seems three teams are yet to get an AC on any one of the problems yet. Okay, IIT Delhi on the spectrum first with five problems, CMI second with five problems, then IIT Guwahati Gufa with IIT Kanpur using namespace ICPC, IIT Hyderabad ETHOS, IIT Delhi Touristers, and IIT Gandhinagar Way to AC have four problems each. Okay, one more AC on outcome, by the way. Looks like IIT Kharagpur WA on test case 2 has also got an AC on outcome. Okay, like this is the live submission queue we have right now. ABC stamp is getting ACs. Like the very recent submission was by team 05G, which is VIT Chennai. Let's check if anyone has made any attempts on any of these problems so far. Okay, so listen to see the balance subsequence. Yeah, like if I have to provide it in main line, I think we can go it with the greedy idea. Let's first try to forget about the prefix part. Like, how will we solve this problem for the complete string to begin with? The idea I would have would probably be I will try to take as many characters as I want. So let's say I start from the first character and I maintain a variable where, or I think I can probably take a whiteboard here. I think I will formally prove the cascading operations as well. I think we can start with first the cascading operations as well. Like the cascading operations, we have been given a string which looks like this, right? We have proven that initial string length should be odd to begin with because we are relating to two characters at one point of time. And if whenever we insert one more character, let's say somewhere here, then we should have even number of characters. That is only possible if total number of characters are odd. Now let's say we have inserted a character here and this character is equal to this character, let's say. Because we have been given no continuous characters are equal to begin with. So in the starting, in the first operation, these two characters would be deleted. And once these two are deleted, like this is the only new pair of adjacent characters which has found right now. So the only possible way to delete some operations right now is s2 is equal to s4. So let's say these were also same and we ended up deleting it. Now the only new pair of characters we have got is s1 and s5. So like the only possible value of equal characters nearby is s1 and s5 only. And you see, we were not able to complete the remaining s6 and s7 as well. And that gives us an idea like there would be some character nearby which we will insert a new character here, and then everything just before and after it should be equal, and so on. And like this holds only for odd palindromes. Like this will probably be the solution on how to solve this problem. Like the string should be palindrome and the string should also have an odd length here. Like because you see like when you have, and in fact that's actually not possible in the input. Like in fact we can just check palindrome and that should be fine. We don't even need to check the length. Because for example, if we have an even palindrome, then you can see these two characters are equal. And problem statement says like no nearby two characters would be equal. So in fact, like we cannot have a test case which is of even length and is a palindrome. So I think just checking palindrome, yes, that should work. So yes, that's a neat idea by the way. So just check if its string is a palindrome or not, and that should be fine. Even palindrome does not appear on the test cases. Odd palindrome, there is a way to solve them, and that would be the idea for this problem. For the cascading operations, which has been solved by I think all except three teams probably. Assuming like number of teams are 108 right now. And like looks like the submissions on good subsequence are increasing right now. Team 087, 33, and 73 has recently solved them. Team 87 is fake coders from Reply T Allahabad, 33 and 73. Okay. Team 33 is IIT Mandi Binary Beast. And Team 73 is VNIT Nagpur Spec 3. And looks like we have almost 1 hour completed in the contest. And number of district problems solved so far is 5. And we have around 12 problems to solve today. Okay, one more AC by team 003 on good sequence. Which is team Hey Hey I Do CP from IIT Roorkee. status of IIT Delhi. Okay, IIT Delhi is at first, 6 and 35. First team is on the spectrum. Sixth team is Touristers. And Mangal Daku is at rank 35. 543 is the ACs right now. IIT Hyderabad. IIT Hyderabad is at rank 5 and rank 29. 4 and 3 sources. ETHOS is at rank 5. And 100 Sage is at rank 29. And it looks like Team CMI is probably close to an AC on this one. They have a runtime error in their code. And probably I think I can take a look at what their mistake here is. Okay, triple IT Basser. I think I can check that one too. Okay. Okay, I was making the wrong spelling. Yes, yeah. Sorry about that. Okay, we have only one team, which is Rajiv Gandhi University of Knowledge and Technologies. I'm assuming this was the team you were asking for. And they have solved three problems right now and are at rank 88. RGUKTB is the team name. Mhm. Mhm. Arithmetic sequence is also an interesting problem. The problem statement says let's define the array B1 to Bm to be good if there exists a permutation of Bm to Bm that is an arithmetic progression. Formally, the array is good if there exists array C and D such that all of the following are satisfied. C, D, B, length of C, D, and B is M. C is a permutation of integers from 1 to M. That is, each of the numbers from 1 to M appears exactly once in C. Let's define Di is equal to B of Cith element, like basically Cith element of B. Then Di plus 1 minus Di is constant for all the integers we have. You are given an array A of length n and q queries of form L to R. For each query, you must print the array whether this AL to AR is good. The queries given to you are in encrypted form. Let's suppose that in the current case there are X queries so far whose answer is yes. and the query is given to you is ls hardest, then you should encrypt this in the following ways. So basically, to answer the next query, you should know the answer of a previous query. For C, do we require DP? No, the answer is no. Like, definitely not all teams would be able to solve a DP problem. This is supposed to be the easiest one. So that's where we are. I think I can potentially jump to problem C as well. We define a set of balanced strings in the following way. Like, I think I have already read out the problem statement. The idea is like, first, how do we solve it for the complete string to begin with? Like, let's see what we can do it for the complete string. Prefix would come later on. Like, let's take one of the string first. Like, the idea is to greedily try to match it. Let's start it from the first string. We have this as open bracket. So we can kind of maintain a stack here, or we can replace opening bracket with +1 characters and closing bracket with -1. So like the problem now reduces that prefix sum should never be 0, should never be less than 0, and we should have 0 prefix at the end. The idea would be like, let's start from here. Let's take this opening bracket as long as we can. Now this is also an opening bracket, so let's take it. Now this is a closing bracket, so we can remove the opening bracket here. Now this is also a closing bracket, so we can also assume that these two characters have been paired. So the answer is 4 right now, and we have an empty stack. Now we came up with an empty bracket right now. So we should probably ignore this character to begin with. We cannot, because we did not found any matching opening bracket in the back. Now we found an opening bracket again. Then we found a closing bracket again. So we can potentially assume this is matched with this character and remove it from our stack we have. Now we have opening bracket again. Let's add it in the stack. Let's add it in the stack. So the answer would end up being the number of characters we ignored and number of opening bracket that remained to us in the end. Oh, sorry, I did not realize screen was not visible. Let me share it again. So I'm surprised, like, even my last time would not have been visible, right? I had some proof even for the previous problem as well, by the way. So this was the idea, like if we are inserting here, then these two characters would be first equal, then these two, and now we are left with these two. So only possible way to do it is wherever we insert the character here, we get nearby character and get an odd palindrome. Okay, this was visible. That's fine. Okay, so the idea was I started with one random example here. Let's say we have some opening bracket and some closing bracket opening closing here. The idea is I replace each opening bracket with a +1 and each closing bracket with a -1 here. And I iterate it from here from the in the order. Let's take an opening bracket. Whenever opening bracket comes, we will take it. And whenever closing bracket, we will try to see if we found a matching opening bracket. Again, an opening bracket, we have taken it. Now we have found a closing bracket. So we match it with this bracket we have. This is closed now. Then we found again a closing bracket. This time we will match it with this bracket we have. Now we have one more closing bracket, but we do not have an opening bracket here. So let's just ignore this case here. Now let's take new opening bracket came in. Let's take it here. Like although the string drawing looks like we are changing the order here, we are not. I'm just trying to show which bracket we have matched over here. Then we got a closing bracket. So because we have one unpaired opening bracket, we just match it here. Then we have few more opening brackets. So we will end up with this like this. And the answer here would be number of closing brackets we have ignored, which is one. Or probably the number of brackets we have paired so far, which would be 2 into 3 here, which would be 6 here. So like the answer turned out to be like the number of closing brackets we have ignored while trying to process it, and number of unpaired elements that remained when we have processed the complete string. Ignored closing brackets plus number of unpaired new brackets we have. And now you see if you are processing in the increasing order, you can just maintain the count of closing brackets you have ignored, and you can also maintain like what are the current count of current unpaired opening brackets we have. So you get a closing bracket, you either decrease this count or you may add it in the ignore count, etc. And the sum of two variables would end up being our answer here. Yeah, we can also use prefix sum based approach too. Like the idea would be like we would need minimum element in the prefix sum, and like that might not be enough actually. Like prefix sum might not be enough. Like we will have to ensure like whenever we get a negative value in the prefix sum, we change it to 0 and we ignore that element there. Or another way to probably look at it is like we need the minimum value in the prefix sum and maximum value in the suffix sum, something like that should work for us. And some of absolute values of both of them can give us the answer. Okay, looks like we have two ACs on arithmetic subarrays as well, which ends up being the sixth problem to get an AC. Okay, the ACs are by team 008, which is IIT Hyderabad 100 Sage. First team to get an AC on arithmetic subarrays. And then we have team 0027, which is ICPC, nice name, National NIT Tiruchirappalli. So like they might have jumped a lot in the rank list. Okay, looks like we have more teams with 5 stalls right now. ETHOS from IIT Hyderabad. IIT Kanpur is using namespace ICPC. Then we have Tiruchirappalli ICPC, like the recent team to get an AC on arithmetic subarray. Then IIT Kharagpur WA on test 2 with 5 stalls. Then IIT Bombay DDD with 5 stalls. And IIT Varanasi prefer not to say at rank 8. I think they were the same team which got rank 8 in Amritapuri. So right now they are at 8th rank and this rank list may change soon. Okay, looks like the rank lists are updating every 10 minutes here. Okay, what should be the max solve count? I believe it would be around 10 or 11 problems. Definitely 12 are not solvable and 11 might be hard as well. And considering the rate at which teams are solving, like probably 10 looks more realistic. 11 is possible, but solving all 12 is definitely not possible. I can just set are these submissions. Okay, IIT Roorkee is trending. It looks like the standing is still same. Team case testers is at 5 solved. Team mushroom is at 4 solves, rank 32. Hey hey, I do CP is at 34, rank 4 solves. And team bite size dreamers is at rank 63. Like they have quite a good number of penalties here. Okay, like someone on Code Forces has prediction on the spectrum. I said and I do CP. So essentially, IIT Delhi, CMI, and IIT Roorkee here. Okay, IIT Hyderabad. Hyderabad is at rank 3 ETHOS 5 solves. And then we are 100 surge at rank 21. And they were the second team to solve arithmetic sub progression, arithmetic subarray. So they have an how odd remaining here, or odd composition. Yeah, how odd. So they can potentially solve the sixth problem right now, which a lot of team have already solved, and jump to third rank right now or second. Okay, so it looks like CMI has solved six problems right now. And the very recent problem, okay, they have found their bugs in arithmetic subarray and got an AC with it. Okay, I think you can see the problem statement on this blog. There is a Google Drive link here.
Hello, hello, hello.
Okay, I think I am back now. Let me know if I am audible.
Yes, yes. Hi, Aryan. Hello. Can you hear me?
And we also have Sren with us. Hey, hi Sren. Am I audible?
Hi, Aryan. You can hear me, right?
Just give me a minute. Hello, hello, hello.
Hello.
Hey, hi Sren. I think you are audible now.
Yes, hi.
And hello, like people in the chat, are you guys able to hear you? Like, looks like I will change my headphone once. Give me 2 minutes.
Hello. Hello. Am I audible?
I think I'm back, and I think I can hear you, Sren, this time.
Hi.
Yeah, hi.
Okay, finally. There we go.
Yeah, there you go. Hey, hi, Sren. Welcome back to the stream today.
Hi,
So,
Aryan.
hi. So, what do you feel about contest today? Like, is it
Uh,
similar to what you expected teams to solve, or
till
like teams
now,
are
I
performing?
think that also on little on the lower side. Like I expected at least some two more problems to be solved by now.
Okay, so that's fair. Like, I think that we were expecting six ACs in the first hour itself. We had
Yes,
five.
yes, yes.
And now it's close to one
Nearly two
hour
hours.
for 100 minutes or so, and we are only at six.
Yes.
So, like, which is your favorite problem for today?
F. Easy counting
Okay,
problem.
okay. Definitely, we won't be discussing the solution until we have some essays on it. But yeah, like, I think the idea was pretty nice here. At least we had the similar problem in Kanpur, and we were discussing, can we change this condition and make something out of it? And that's how this problem for Chennai regionals was born here. Like,
Yes, and also it is like it is much harder. The previous problem in Kanpur regional was called hard counting problem, and it was easy. And this is called easy counting problem, and it is hard.
so problems such as trolling people here, and yeah, so like the problem statement similar to setup is similar to the previous one. Here it says we have an array A of n elements, and once we have at any point of time we fix the maximum index where ai is equal to I, and we delete that element from the array, and then elements are again rearranged according to the original indexes, and in the reindex array we again try to delete elements. Each element of the array can be up to m here, and total m to the power n possible values. F of a is defined as the time when array we stop deleting the elements, and we have to find sum of all these elements given some modulo mod. Yeah. So yeah, like I think I like this the problem odd component here.
Yes, yes. This was also
Yes.
nice. We can discuss this now.
Mhm. Yes, sure. So I can leave it for the chat ones if they want to try out. It says you are given a simple and directed graph G with n vertices and m edges. It is also guaranteed that every simple cycle in G has an even length. Let H denote the graph that is complement of G, that is simple directed graph on n vertices which contains edge u and v if and only if it does not appear in G. Find any simple cycle in H whose length is odd or claim that none such length exists. And some formal definitions are given. The constraints are up to number of edges, number of nodes is up to 2e5, and number of edges is nc2 2e5 here. So, by the way, what do you think who would win today? Like right now, I think
Yeah,
that rank list.
CMI is best guess.
Okay, like we okay. Current rank list has some surprises. CMI, I shared the winner of Amritapuri Regional is first right now in terms of penalty. Then we have NIT Trichy, which is ICPC, which has six ACs right now. Then we have IIT Hyderabad, which is ET 100 sage. They have solved the sixth problem. I think they were the second team to solve the arithmetic subarray problem, and they have tackled the other problem here as well. So they have also
I
solved
think has a
Harvard.
wrong answer on B. Has a wrong answer on arithmetic sub problem. Two
Which
wrong
team?
answers now. IIT Delhi, the fifth team.
Right. Okay, on the spectrum. Okay, they have two. Are they getting E is cascading operations, right? So is it problem E or some another?
What? No, I'm saying
One
in
second.
problem B, arithmetic subarrays.
Problem E. Okay, problem B, not E. Got it. So like these are the current ACs right now,
New AC
and
00.
001 is IIT Delhi, I believe. So like, what do you think? Are they close to the solution, or they will have to
They-
completely
Like,
change?
since you know the solution, they actually found out GCD of elements instead of differences.
Okay, got it. That's a problem here.
I'm not sure. They haven't noticed yet.
Yeah, like probably someone will look at it and find the counter test cases and get something done. So that's where we are. Okay, any problem you would like to discuss? I think potentially the choices we have is we can probably start with G first, and then
Yeah,
we
sure.
can probably go for it. Okay, like I think this is automatically refreshed. Like the con job might not have run right now, and we can check once. Like probably I will wait for 5 more minutes, and if it's not updated, then I can probably ping someone to see why it's not getting updated. Okay, the problem G was like we call a sequence good if only half of the element are fixed elements. The definition of fixed is defined same as previous one, where bi ith element is I. And now we have been given a sequence of length n, and we want to find the longest good shape sequence in A. And we have to find this value, and if no such value exists, we can no such sequence exists, we can potentially print zero here. So like, so were you the author of this problem or someone
Yes,
else
yes.
was the author?
I was the author of this.
Okay. So like, how did you probably came up with this problem idea?
I don't really know. Like, it was pretty random only. And you can see I was
Okay.
playing around with fixed indices, especially. Like, another problem, F also had it.
Right. So you had hard counting problem, which was in fact easy problem in Kanpur regional, and now we have easy counting problem, which is in fact hard problem. So you
Yes,
probably noticed one of the observation and ended up submitting it.
yes. So this problem has a pretty like interesting solution, pretty funny solution.
Yeah, and like we were also playing with majority elements for Amritapuri
Yes,
as well. Like,
yes, yes. So it's
so
basically along those themes.
yeah. So like, do you think if anyone knows the solution of both of the problems, the Kanpur hard counting problem and Amritapuri's majority element problem, they would be able to
No,
instantly solve the problem?
they don't really have anything to do with each other. Like, I don't think there is that much relation between the problems,
Okay.
solution wise.
Got it. So probably people in the chat, do you have some ideas on good sequence before we ask Sam how to solve this problem? And we can probably quickly check if okay, looks like someone is attempting bin packing as well, which is Srinagar University from Chennai. I'm not sure if they are close or not. And looks like no one has even made any submissions here. Yeah, like Okay, someone is suggesting probably try out DP for this one, but the constraints are way too large. So yeah, that's correct.
Let's discuss the solution then.
Sure. So I think I have a whiteboard with me as well.
So the
One second. Okay, yeah, I think I'm ready. I have sent out the comms that rank list looks probably frozen. Let's see if someone takes a look at it. So yeah, like how do you think we should potentially approach this problem here?
so we should first like if, since we want to find the length of the longest sequence, we should first check if the sequence like the whole sequence can be taken, and what is the
Okay,
condition under which it cannot be.
okay, let's say A4 up to A and we have. So your
Yes.
first suggestion is we should take the complete sequence to begin with
Check. Try to
because
check if
this is the maximum possible.
yes.
So check if possible or not.
Okay. If it is not possible, then we know that there are at least more than n by 2, greater than n by 2 element indices such that ai equal to I.
Okay, if answer is yes, print n.
Yes, it is fine.
Yeah, and
Like
if
this
it's
is the,
no, then we know that at least half of the elements are AI
ai.
equal to I. Right.
So what we do is that we simply just okay, now we consider the sequence from 2 to n. So we delete one and then we consider the remaining sequence.
So you are saying I just delete this sequence and I just take this one out.
Yes. Now what happens is that every element's index gets shifted by 1.
So you are suggesting like all such elements here, their
Indices get
new index would be
becomes
I minus one.
exactly. So
So
it can't be equal because the index is now different.
right, bi is not equal to bi is equal to I, which is not equal to I minus one.
Yes.
Yeah,
So basically and you can check that there will be at most so there are greater than n by 2 things before, so it satisfies the condition now.
right. Okay, because now we have greater than
Now we have greater
n
than
by
n by
element
n by 2
which
minus 1.
satisfies.
N by 2 minus
Okay,
1. Because we deleted first index as well, right?
right. Okay, yeah, this can potentially be the case here.
Greater than n by 2 minus 1 indices such that bi is not equal to I.
Right,
Greater than, strictly greater.
strictly greater. Right.
And so this guarantees that this is a valid sequence.
Okay, like okay, then won't we run into an issues here? Like for example, let's say we had earlier n equal to 8 element. N
Yes.
by 2 minus 1 will give us 3 elements, right?
No, 4 elements. Greater than, strictly greater.
Okay, so you said that for 8 we had at least 5 elements, then only the answer was no.
Yes,
So
then
if
only the answer was
we delete
1.
one element from here,
So we still have 4 elements
and
left.
we if one was fixed, then we will have 4. Otherwise, we will have 5.
Yes,
And both of these are greater than 7 by 2. That makes
greater
sense.
than 7 by 2. Yes, that is the main
Okay.
idea. So the
Okay.
answer
So we
is
also
either n or n minus 1.
okay. And one more thing, probably if I have to check, I will probably also check for the odd case, right? because
Odd case
n by
also, yes, you can say.
2, if I have, let's say, n equal to 7, then my fail condition happens
At
when I have
four
more
elements.
than 3.5
Three, that
element,
means so
greater
four
than equal to
elements.
4.
Yes. That
And
means that
if I
greater than equal
delete
to
one element 6, and here if I will have greater than equal to 3 or 4 elements, based on whether the first element was fixed or not.
yes.
And okay, and looks like here also the condition would be satisfied. 6 by 2 is 3, so not more
Yes.
than half. Okay,
Yes.
this makes sense. So the answer is we just check the original sequence. If it's present, we print n. Otherwise, we blindly
Otherwise,
print n minus 1.
-1.
Okay, this one makes sense. Any questions, anyone?
No solves yet. No new solves yet.
No. Mhm.
A lot of 600 teams.
Yeah. Okay. Okay. 7 teams at 6 and no team at 7. And we are close to 2 hours mark now. Let's probably check if what teams are submitting them. Okay, teams are mostly still working on ABC, odd count, good sequence, etc.
Let's discuss the odd comp problem soon as well.
So, okay, yeah, like I think let's take 5 minutes and then we start at 11:10.
Okay.
So yeah. So like people in the chat, if you want to try this problem out, you can do it right now. Otherwise, we will end up spoiling the idea for you. In simple terms, the problem statement is like this. We have been given a graph which says there is no even length there, no odd length cycle in it. We have to take the invert of the graph here. Like basically, we take a complete graph and we delete all the edges which are given to us, and we have to find one cycle which is of odd length, or we have to claim that no cycle of odd length exists here. So that's the idea. Like n is up to 2e5 here, and that's where we are. Okay, Anup says since graph will be bipartite, if any component is greater than equal to size 3, then yes or no. What are the pragmas like? I think like these were some random statement I ended up copying. Like I don't really know what all these methods do, to be honest. Like I just know like they sometimes make stuff fast, so I have just blindly copied them here. You can probably look out at pragma code forces. You can probably check out these some of the blogs to see what black magic kind of thing these pragmas can do. Three queries for order OQF. Speeding up for naive algorithm. There is one more code forces blog. And GCT optimization pragmas is again a one more blog. Okay, references for n greater than equal to 5. Pick any three nodes from one side of bipartite graph. For n equal to 3 and 4, brute force maybe. Yeah, like something on those lines can work here.
So the idea mentioned was correct, like the person in the chat. The idea
Okay,
is definitely. So
okay,
the
because
guarantee that there's a first the
okay,
guarantee that there are no odd cycles in the graph. That means that the graph is bipartite.
okay, no, odd cycle means bipartite graph.
Bipartite graph.
Okay,
So then we draw like we split it into its two components.
okay. Let's say we have a graph like this. Like basically, we can split each edge into two components,
Yes, so we
and
can
there will be
bicolor the
no
graph.
edges by color the graph. Let's say one
Yes,
of type this and one of type this.
yes, sure. And now
Okay,
the idea is that if the any of the component if any of the components have size greater than 3, greater than equal to 3, then you can just output any three elements of that component
okay. So for
because it will
example,
be a
this
click.
component has four. So
Yes, so
let's say I think
by definition, a bipartite component has no edges between its nodes in the same component. So
right.
therefore, it will be a click in the anti-graph, in the complement graph.
Okay, so for example, if this is how bipartite look like, and if I pick any three nodes of the same color in the bipartite graph,
Then they will be connected.
all three of them would be connected like this because there were no edges between these three to begin with.
Yes.
Yeah, this actually makes sense.
And this works for n greater than equal to 5 because n greater than equal to 5 by pigeonhole, you're guaranteed to have one component which is greater than equal to size 3.
A pigeonhole principle. One component will have greater than equal to three sides. Or another
Yes.
way to probably look at it is we can have like at max two nodes of color red and at max two nodes of color
Two
green.
nodes
And
of
if we add any load, then we will either end up with pink or green, and we will end up with five nodes.
yes. And so for n less than equal to 4, we can just brute force in any way you want.
Okay, so like for n greater than equal to five, answer is always yes. And for n equal to three or four, just brute force.
Yes.
This actually makes sense, and I think this is the expected idea.
Yes. And there are some other methods you can use, so which I'm sure
Yeah,
you're aware of.
yeah. So like I think we can in fact actually just write this statement equal to n minimum n equal to n comma 5 and then
Yes, yes.
just
And
brute
then
force
brute
on
force
the
over
complete
all
graph.
possible. Yes.
Brute force for I equal to 1 to n,
Yes.
j equal to 1 to n, and k equal to 1 to n, or whatever we want. We can probably
Yes.
make
This
it
is
I
the
minus
model
1,
solution as well.
j minus 1, and just check there are no edges on all this. Because we cannot have for loop because we want odd length. So the only possible we know, like for any, we need three nodes at least. And for n equal to 3 and 4, we are trying all the set of three nodes. And for n more than 5, we definitely know a cycle of length 3 exists. So technically, or we will always end up printing a cycle length 3 cycle.
Yes.
So this was an easy solution, which a lot of team would have realized it.
I'm actually
And
surprised. Even now, only 30 solves there are, despite
no,
it
I
being
think
solved.
like when I said what I did while testing, then people might understand why this was not there. Yeah. So what I
But still,
ended up doing was, yeah, what I did was I actually did DFS in complement graph.
yes, which is like not that easy to implement, like not
Yeah,
compared to the intended solution at least.
yeah. And the idea is like if we know the current edges, we can even actually do a DFS there. And the idea was when we are doing DFS, we can probably color it in the ways we want and find. Like if we have the original graph, then we can run a DFS there to find whether it's biparted or not. And if it's not, then that in fact gives us two violating condition. So we can probably look at parent etc. to get the node. And there is in fact actually a code forces blog which
You should add code forces.
and looks like someone also has a video tutorial on it as well. The video of DFS. Oh, 1 second. I think I will probably switch to Google once.
It's the first blog, I think it should be.
Traversing, yeah, traversing the complement graph in linear or near linear time in multiple ways. Yeah, like that's what I ended up doing instead of three for loops, and you can probably find it here. The time complexity was roughly this. M is the number of edges in the complement graph, like basically the current graph, and N is the number of nodes. And DFS can probably be done in this much time. Like this one probably requires less brain but more coding time. While
Yes.
realizing that N equal to 5 graph, the answer is always yes, is just few lines of code. And as people have said, like reading 5 minutes of document can save you 10 hours of debugging. So essentially, that's what it is. And actually, doing it this way does not even requires
The bypart,
doing
you have
it.
to be bypart.
Yeah, like you can use this method even if it was not given to you. Like every simple cycle has
Original
given.
problem was going to be either print an odd cycle in G or print an odd cycle in the complement graph, but then I thought why give them printing odd cycle in the original graph? Like I just
Okay,
guarantee that there is no odd cycle in the original graph.
right,
Oh,
okay,
there's an AC
right,
on XOR 123.
right. Which team is it?
It is the prefer not to save from IIT BHU.
Okay,
I'm still
looks like
surprised that I wasn't expecting this to be the next solved problem. Okay, it's like one away, I guess. One problem only is left, which is
right.
not.
Okay, so prefer not to say from IIT are the first team to solve ZOR 123, and this will potentially bring them up on rank 7, right? With 7
Yeah, they
ACs
are
at
rank
that
one.
time.
They are rank one.
Okay, this rank list was recently updated, the mirror rank list we have. And now IIT is at top. 7 solves, prefer not to say. And yeah,
Overall, still though, it's very slow moving rank list.
no, like at least it's faster than the Chennai regionals we had last year. Like Those who do not remember it, like last year, like Chennai regional was the hardest regional we had,
Yes.
and
Content. Oh yes, it was not showing over here for some reason. I'm not sure why. I also saw this a few days ago.
okay, I think we have. I think I can search it via this. Not sure how do I search it for portals. Mhm. Yes, this was the rank list. And like the winner team ended up solving just five problems in a problem set of nine.
Go scroll down to rank
Mm,
15.
yeah. So first 14 team had similarly five solves and four solves, three two.
No, but I think the rank 15 is interesting.
Okay, so okay, yeah, this is your team, right?
Yes.
Yeah. So you had five WAs on basic rooms.
No, that was we were just submitting to make teams think that it was easy, but then it also turned out to be the next easy problem.
Right.
All the links are not opening. Okay, wait, scoreboard opened at least on me on code drills. It's just taking a lot of time.
Okay. For me, just shows. And yeah, like someone mentioned out connected components problem here. Like this is actually the first problem which blog mentions here. I will focus on solving this problem, which is connected components from code for educational. Okay, looks like someone has solved arithmetic subarrays as well. Fitch team 80.
Prefer,
ETHOS from
prefer,
IIT
not to say
Hyderabad has
our,
also solved subarray one.
prefer not to say our first, but they have a lot of penalty.
So, like the first time anyone else solves, they will jump forward. Right.
We can also show like read bin packing problem.
Okay, like wind packing, like the idea is definitely interesting. This is
And
on
the
the harder
problem
side.
problem is
Yeah,
also quite unusual.
yeah. That's all an NP hard problem today. There are n objects, the ith of which has size AI. AI is between 1 to 12. You have several bins of size 12, and multiple objects can fit into same bin if and only if sum of their sizes is less than equal to 12. Find the minimum number of bins needed to fit all the n objects. So this setup is definitely NP hard. Now we have some special constraints because
No, the setup is not NP hard with the constraint that AI less than equal to 12. Like even a
yeah,
naive solution is just n to the power 12.
Oh, right, that's correct.
Yes, so it is not NP-hard in the given constraints, but in if AI was unbounded.
Like up to, let's say, some m would have been generic, then it would have been a problem.
Yes.
Okay, and then the special constraints we have is for all the non-sample tests, the number of tests and number of objects are fixed. There would be 100 tests in each file, and there would be 1,000 objects. And the object file will also be generated randomly. Basically, for each AI is chosen uniformly random from 1 to 12 here. Please note that really hard time limit, so it may take a while to judge. We recommend you to run your code locally on Backstress to estimate its running time before submitting.
It's a
So
10-second
looks like
time limit.
10 seconds time limit. And it also says there are exactly 19 non-sample test cases.
Oh, recursion got solved. The J got solved. Recursion.
Okay, very nice.
It is by ICPC, the NIT Trichy, I think. NIT, no, yes.
027. ICPC, yes, and ITTH, and this will potentially bring them up on the rank one, right?
Top right. They should be first now. Or maybe second.
Okay,
Okay, it is
this,
updated.
yeah, this is not updated yet.
They should.
Okay, and
Okay, it will be
then,
close.
yeah, so it will take 2 minutes, and NITTH would be at top. Then we will have NITTH.
The supply, like recursion was the problem. There is still one problem that is expected to be solved. I expected it to be solved in the first hour or maybe first 90 minutes, but it's still unsolved.
Which problem is it? Max is
Max is,
fun, I believe. Right.
yes. That is the last easy problem left in the set, I guess. Relatively easy, I mean.
Yeah, definitely relative is the important word here.
Yes, yes.
And we also have Asis who is on site right now. And he was suggesting he can potentially join on a mutant. So, like, what's happening on site here? So, like, we may have some visuals from on site, but yeah. Looks like it's updating. And current rank list as it stands is NIT Trichy is at top with 7 aces. Then we have IIT BHU with 7 aces, prefer not to say. And then we have multiple teams with 6 aces, CMI, ISAD, IIT Delhi on the spectrum. Again, IIT Delhi, tourists. Then IIT Hyderabad, ETHOS, IIT Hyderabad again, 100 Sage, IIT Roorkee again, IIT Roorkee, hey, hey, I do CP. Okay, NIT Trichy, I can check for it. 1, 2, 3, 4, 5, 6, 7. So NIT Trichy, the team at the top, has only 7 aces so far. Okay, I think I can go one by one. NIT Trichy, only one team which is at the top right now. Then the next in line is IIT Patna. Sleepy Giants is at rank 13 with 5 salts. Meow 5 salts rank 17. And okay, probably I will avoid the name here, but you can see the name here, which is 4 ACs rank 40. Okay, next is Walchand College of Engineering. Let me do it. Walchand College is at rank 54 with 4 ACs so far. Okay, then the question was top 3 teams. Top 3 teams is NIT Trichy, ICPC, then IIT BHU Varanasi, 7 ACs, prefer not to say. Then CMI 6 AC, ISAR. Then VIT Chennai. First team is Boa Constructors at rank 21, and then Ternary at rank 54. 5 aces by the first team and 4 aces by the second team. Manav Rana University. Manav Rana rank 75, 4 aces. The team is it so? IIT Delhi rank 4, 5, and 21, 6, 6, 5 on the spectrum. Tourist and Mangal Daku. Okay, we have Ashish with us who is on site right now. And if anyone wants to look at visuals of on site. So those were some live visuals from the on-site which Assis has shared with us on the form. And there is one more lab, lab 3, which he would be sharing. Oh, sorry, Ashwin, not Assis, Ashwin. Sorry. So I think we would be back with the rank list. Okay, thanks Ashwin for sharing with us the live visuals. I think we tried to cover all the teams. Suren is also back with us.
Hello.
Yes,
Hello.
that's it from my
Hey,
end. Sorry, the mic was on mute.
yeah. Hey, hi Ashwin. Hi Suren.
Hi.
So yeah, I think would you, if we would have also had access to what different teams are doing on computer, that would have been made things a bit more easy because on rank list I see no one is submitting anything.
Actually, like
Everyone,
three new problems got solved recently, like relatively recently. Maxis 1 got solved, recursion got solved, and XOR 123 was solved some time ago.
okay, I think we can probably give them a shout out once we are back with the stream. Yeah, thanks Ashwin for joining us today, and I think he's probably talking now.
So
So
recursion and XOR 123 got two solves now.
yeah, so like these are the new updates here. Recursion has two solves right now, like 027 first and 011. 027 I believe is ET Hyderabad NIT Trichy ICPC that made them the first team, and then 011 is IIT Bombay DDD. Then we have ZOR 123, 022 and 033. First AC was by team IIT Varanasi prefer not to. I believe this makes them with 8 aces, right?
Which team?
IIT Varanasi, and then IIT
No,
has
I
also
think they
solved
only have
this
7
problem.
right now.
I do CP, and then we also have an AC on Maxis Fun, which is 082, which is IIT Hyderabad again 100 says. So they are probably trying harder problems first. And if I probably move back to the scoreboard now,
CMI and like CMI and
IIT
Delhi
Delhi
team have not yet
has moved
done 7
right.
on the
So
spectrum.
they have moved to fifth and sixth rank, and the team
Yes.
at the top is IIT Trichy. Then IIT Varanasi, prefer not to say. Then IIT Hyderabad ETH 100 says, not ETHOS. Then IIT Roorkee, hey, I do CP. Yeah. Okay, how much time? Like, I think only half contest is over so far. So they have around 2 hours, 20 minutes still remaining.
Yes. 9 solves might be like there are 9 distinct solve problems right now. So I
Mhm.
guess 9 solves will be by 3:30 or 4.
Right. So like now, like every team will realize these three problems are solvable. So they will
Yes,
probably
yes,
jump onto this problem.
yes.
So we also have one of your fan in the contest. He says no dominator in contest, no fun. He would solve all the problems. So that's where we stand right now. Yeah. And I think I will probably the rank list is was updated 10 minutes ago. So you
Yes.
can probably look at your favorite teams right now. IIT Kharagpur. IIT Kharagpur 1 WA on test list 2 had 5 aces, and error not found had also had 5 aces on rank 27 and rank 11. Triple IT Hyderabad has a team Lazy 3 which had 4 aces until 10 minutes ago. Logged in has 4 aces. And IIT Hyderabad had quite a close competition between ETHOS and 100 says. And 100 says has solved one more problem to move to the top here. And I think someone was also asking for Bhubaneswar.
Oh, prefer not to say got 8 solves now.
Oh,
They
wow.
just solved recursion as well.
Okay, I think like these problems require probably less code, but more thinking on paper. So although we are not seeing much progress on the scoreboard, but it's actually possible three members are solving three different problems on paper.
Yes, yes. I guess prefer not to say as Max is fun left for 9, which they should get maybe in like they can get it in 20 minutes, I think. Like it is it is doable in that much.
Like doable with respect to code is definitely 20 minutes, but it depends like how much they take to find out. Like idea has definitely appeared few more times in the past. So yeah,
We can maybe discuss like either we can discuss maybe Max is fun, I guess.
okay. I think at least I can read the problem statement out, and then we can probably go for arithmetic or something. So maxis one problem says we are given two sequence A and B of length n. You need to perform following operations to construct an array C of length n. For all the indexes I, Ci should either be equal to Ai or Bi. And the goal is we want to find the maximum value of the max of all the values we have taken independently for all the
You have to
prefixes independently.
solve the problem for every prefix basically.
Basically, okay. And max is smallest non-negative integer that is not present in the sequence. So essentially, first let's solve for the hard part first, and then prefix can probably be optimized further.
Yes, yes. It is pretty like the solutions are pretty much the same except for like some details. Like you have to
Yeah.
just do it in more optimized way.
Yeah. So this problem statement basically says we have two arrays. We have to construct a new array where we have to take one element from for each index from both of the values there, and
Either
then we
one.
should either one, and then we should find the max value over here. And I think people in the chat were also asking for arithmetic subarray, but I think I haven't even read the problem statement yet, so I can read it. No, I think mm, I have read it once, but we have not discussed it yet. So I
We
think we
can
can
discuss
probably
both.
discuss arithmetic subarray.
Sure,
Yeah, like
sure.
basically I was waiting for some more aces on Max's one before jumping there.
Okay, sure.
But yeah. Yeah, but I think I can definitely go for arithmetic subarray. To summarize the problem statement right now, like it says we have to solve some queries. We have been given some index L to R, and we have to print yes if we can rearrange all the elements from L to R in some form so that they form an arithmetic progression here. And one more additional constraint was we will find out what the new query is only after we have solved the previous query. So we don't really have much flexibility to with respect to algorithms here. Like whenever someone asks us to find some subarray, we have to immediately answer them before even we read the next queries. So there are okay. Problem A. I think we haven't discussed problem A either. We can probably go for that later. Yeah.
Yes.
So yeah. So this is the problem statement. And in fact, actually, there are multiple ways to solve this problem. We are aware of at least two ideas. We had two different solutions here, and it can be more. I think I can probably just open the whiteboard and just draw one of the samples here. So, Srayan, Srayan, are you the problem setter of this problem or someone
No,
else?
this was by Matthew Rowe or Chromate on CF.
Okay. So, like any example chat
Oh,
that you
sorry,
would
sir,
like.
sorry. This was not. So I said the wrong name. Sorry. He said three other problems, but not this one. It was actually by VGT official, I think.
Okay. And like he's the regular problem setter for Div 3 and Div 4 on code
Yes,
courses, right?
he has set a lot of div 3 and div 4s.
Okay. So, any subarray you would like to take me up, Swayan, if you want to
Uh,
discuss?
let's just take 513 or something.
Okay. Let's take this one.
Sure.
Yeah.
So
Yeah.
the
So,
core idea is basically like we have to figure out two things, like some things. If we want an AP, then we need to find the what the AP has to be, right?
right. Yeah.
So
So,
the
like,
AP is characterized by two, like AP has two things basically, like the first element and the common difference. And obviously the length as well, but the length is fixed.
yeah, like
That
length we
length is
have
just
been given, which would be R minus
R
L
minus
plus
L
1,
plus 1.
right? So, we need the first element and common difference here.
Yes. The first
That's
element
right.
is pretty simple, just min of the subarray.
Take minimum as the first element. And
Yes.
what do you
Common
suggest
difference is
about
more
common?
interesting. There are some ways to find it. One of the neat ways that one of the ways that actually also leads to a full solution as well
Like, let me just formally write it down. Like first
Yes.
term of an AP can be the minimum element in the subarray, and length of an AP is given to us, which is r minus l plus 1. And we also need common difference here.
Yes, so there are some,
And
like there is a like you can definitely find other ways to find it. Such you can do okay. Let's do the max way, right? Max minus min by ln minus one.
okay, so we can take max element min element divided by length minus 1. If
This
an
gives us a
if
common.
this give us some value of d, now if the
So
answer is yes, then this d will definitely be the common difference.
this is the
If the
actual d
answer,
as well.
yeah, and if the answer is no, then this can be anything.
So we need to now check whether the subarray satisfies the condition of being an AP with this value of a and d.
Got it. So now we
So there are
essentially
some ways
need.
to do it.
So
One of
we
the
essentially
ways,
need, like basically these values should be the permutation of original subarray we have.
yes, yes.
Yeah, okay.
One of the interesting ways that I found to do it was, let's also find out the GCD of adjacent differences.
GCD of.
Adjacent differences.
Okay.
Let's take the 513 example.
Okay.
It will have 4 and 2 as the differences.
So like absolute value of differences. So this
Yes,
difference is
absolute
4.
value as differences.
This difference is 2.
And then we take GCD of all of them. We get 2.
We have 4 comma 2, which is 2.
And we can see that this leads to the actual difference as well. This is the actual difference as well.
AP difference if it exists.
Yes. Now the very interesting claim is that if the values from max minus min by len minus 1, like if the two difference, we got two expressions for d, right?
Right.
One expression is max minus min by len minus 1, and another expression is this GCD of adjacent differences.
AJ
AI minus
minus 1.
aj plus 1, absolute value.
Like absolute value here. Yeah. We have got two differences.
If the values of these two are same and there is no repeated element, if there is a repeated element, we can directly check. Then the array subarray is good as well.
Okay. This is one claim. So
Then
we know like we found two ways to find common differences. Both of them should
yes,
be equal and there should be no repeat element. Then we can claim that
yes,
the answer is yes.
yes.
Okay.
Then the answer is yes. Why? Because whenever we take like whenever basically the idea is that if the otherwise like if it wasn't forming an AP, the right hand equation would be smaller. It is kind of hard to prove like on paper. Like the idea is basically that that would be smaller. We can take another different example, 514 or something, and we
Yeah,
can
that
check
is
that 4 and 3.
and max minus min will give us 2.
Yes.
Got it. This is one way to do
So
this
okay,
problem.
so I will try to at least prove it somewhat. Okay, so basically consider, suppose that GCD is like let's suppose that GCD is equal to D, but and let's suppose GCD is equal to D and there are no repeated elements.
Okay.
And so what let's sort the subarray. The first element must be min.
Right.
What can the second element be? The second element can only be min plus D. Like it can be
Right.
min plus 2D, min plus KD. Let's write it min plus KD. It can
And
be min plus
overall, like
2D.
it will be move more like min plus k times d, where k is different integers here.
Yes, K1. Let's write K1, K2, like that.
Okay.
Then the next element must be min plus K2D, where K2 is greater than K1.
Min. Let me just write some elements.
No, the second element might not be min
Mm,
plus d exactly. It might be min plus
yeah.
kd.
Okay. So you are saying ki, like are
Can
we
we?
are looking at the sorted, right?
We are looking at.
The sorted elements, right?
Yes, so it might be min plus k1d. Like I'm saying, we have not yet found out that this is actually a good subarray.
Uh,
So we are just
Right.
considering what the cases can
So
be.
so you are saying like from a potential sequence like this, some of the elements would be deleted or will not
Yes,
appear, right?
yes. And now the idea is that if max minus min by len minus 1 is also equal to this, then all of them must be present because otherwise the length of the array would get too large or there would be too small elements basically.
If this is equal to max, then all the values would be appearing here.
All the values would be appearing
And
and therefore it forms a valid AP.
otherwise, max would be this.
Otherwise
Got it.
max would be greater. Yes, that is the idea.
Got it. So basically, once we found a common difference, we found the minimum element.
And then
We
all
know
of them
like
must be differing by d, like multiples of d away from min, and therefore we, if max is greater, then we get that this condition like
some
max
element
would.
was missing in between.
Yes.
Got it. Any questions, anyone on this one? Like one more solution we had was like we using min we can find the first element of the AP. What
And
I
then
did
we use
was you can either look at the sum to find the common difference, or you can again look at max minus min to find a common difference.
and after finding common difference, you can use hashing to check if the subarray
Yeah,
satisfies.
yeah, like then you can use polynomial hash. Like polynomial hash, I defined like basically
Here you
x to
need
the
it to
power
be unordered.
al,
So
x to the power al plus one plus x to
yes,
the
you need
power
it
al
unordered.
plus
So you cannot do into I thing.
plus x to the power ar. I just x would be my random number, random base. It would definitely be taken with some mod. Like basically for each element, I would just make it to the power 2 and keep this sum.
Yes.
This is one way to has array from AL to R. And since we know it's an AP, we can also uniquely find what the expected hash should be. And this is basically sum of GP. And you can probably use difference mod, etc. Yeah, definitely you should take X more than one. And like the preferred ideas you can take. Yeah, like so the idea was first thing first, you can since it's a fit system rather than a code forces round, you can definitely just pick one random element. It does not work, you can try another one, and you can hope ki, like after 5 submissions, problem setters would not have a test cases against it if the probability is small. Like, and that was one, and you can potentially use multiple hashes here. Like for example, you can take 1e9, then 983 different one, and you can notice via CRT. Like basically x to the power y percent, if it's prime, mod minus 1 is equal to 1, right? So if you have multiple mods, then you can potentially assume like using Chinese remainder theorem, you can potentially see like if you use probably 3 different mods, then you might be actually good with respect to the uniqueness there. So that was the idea. Like values can definitely be more than 1e9, but if you use 2 3 different mods, that should be good. And in fact, actually, one random prime and base would have worked. Like it's not feasible for us to add a test case against all the possible mods people can think of here. So it mostly boils down to probability.
There are three solves on recursion and XOR 123, but still only one on Mex is fun.
Mhm. So like who recently got it right? I think when we'll check last time recursion had three and Zor
Recursion had
is
three, now XOR 123 also. One team has a constant factor TLE on XOR 123 despite having n log n, but like they just have a really bad kind of, they have bad constant in their code.
for Zor. Okay. I think it's possible to solve in n log n there.
Yes, their
No.
solution is also n log n, but they have n into 20, like n log n memory as well, which is why their time has slowed down a lot.
So is it do you know the team name? We can potentially look at them.
It's just it's some, I think W on TC2 only. Let me check.
Okay, I think there is only one TLE submission.
Yes, W on TC2.
No, it's TLE here. Test case 5. Okay, okay. Team name was WRTC2. Okay.
Yes, you can check. Like they have a triple 3D vector. So
Got it. If I would have been coding it, at least I would make 21 this side and n plus 3 this side.
yes,
Okay.
yes,
And one can probably potentially check here like, does switching 21 and n plus 3 leads an EC or not?
yes. I should check that. But actually, I have to change a lot of the statements. So
Right. So, yeah. I think we had similar, I don't know.
it is
Yeah.
solvable. Like I have a solution in n log n with n memory, and like we have pretty fast solutions. Like n log square also passes in less than zero point 0.5 or 1 second if you have a good implementation. If you use
Okay.
Fenwick,
I
basically.
got it. And I think when I coded it, my solution was n log n memory and n log n time there.
Okay.
Yeah. So yeah, that's where we are. And I think teams are catching up on arithmetic sequence there. So I think among these problems, we have potentially and we have ABC stamp remaining. Otherwise, we have potentially discussed all the easier problems. So I think we can take ABC stamp in 10-15 minutes or so. I think I will read out the problem statement once. There is a
There are
string s of length n. Initially, si is question mark for all I. You can perform following operation any number of times. Select an index I and change the following three characters. Set si equal to a, si plus 1 equal to b, si plus 2 equal to c. You are given the target string r consists of character abc only. Please determine if it's possible to make s equal to r by using operation any number of times. If it is found to be possible, construct a sequence of at most n element that make s equal to r. It can be proven if such a sequence exists, there also exists sequence of size at most n. Note that we do not have to minimize the length of sequences here. N is up to 2e5 and yeah. So chat
I know of
is the
at
problem.
least three different solutions to this problem.
Can you
It,
probably repeat again once?
I know of at least three different solutions to this problem. Some
Okay,
of like, and they are completely different techniques.
that's
One of,
interesting.
uh, I'll not reveal the techniques right now, but yes, there are lots of possible solutions.
So yeah, like qualification, I think it's mostly like this: winners directly qualify for the World Finals, and any other team from that college cannot participate in Asia West. That's the first rule we have, and after that, it's mostly top X team from each regional, where X would be determined based on how many teams participated on site. You can probably find all the rules here: wc.india, icpc.in. This is the selection criteria. Like two different teams from the same college or different college. Okay, same college. I think rules technically allow college ad- admin to decide which team they want to send to World Finals, because World Finals allows only one team from each college, and both of the teams which have top two different teams are eligible for that. And sometimes college decide to have internal selection tests. College admin may say both of you go to the Asia West, and whoever gets a better rank will qualify for the World Finals. Anything is possible there. And one more thing was in ABC stamp, like these were the consecutive elements rather than a sequence there by the.
Let's discuss this problem.
Sure.
So first of all, I said that I know three solutions of this. Like one of them is ad hoc, like constructive, like figuring out necessary and sufficient. You figure out first necessary and sufficient condition, and then construct based on that. Necessary,
Find
and then
necessity sufficient.
construct for sufficient. Construct to prove sufficient, basically. This is I think the hardest approach for the problem, I guess. There are two other approaches. The second solution that I know of is viewing it as a graph problem. This I found very interesting.
Okay, like probably we can tackle all three of them one after the other. Any
Yes. So
example do you
second,
want me to draw here?
we will tackle them. Like let's first discuss what the three are. Like second one, there is a graph toposort approach.
Okay, graph toposort.
And
Okay,
the third one finally is just viewing the sequence in reverse, like reversing the operations basically.
got it. I think like third is the easiest one. and I'm
Yes,
not sure
yes.
about second and first.
Second one is also pretty easy, like implementation wise, at least if you get the idea.
Okay.
First one is somewhat annoying to construct.
Got it. So I think probably, so which approach would you like to discuss first?
Let's do the graph toposort approach because like it is a pretty simple idea, but yet I haven't seen this exact idea before.
Okay.
Okay, so let's take a sequence which is like, let's take a solvable sequence: A, then B, then C, then B, and then finally another C. This is solvable. I know it's solvable because I know the necessary condition.
Okay.
So here what. Hello, sorry for that. Let's so see what happens is that what we want to consider what. Okay, so what we will do is we will perform. There are n minus two possible operations, right?
Right.
N minus two possible operations at each index basically, and you can check that it's never good to repeat an operation. Never repeat.
That makes sense.
This is a pretty obvious claim. So after that, what we want to do is we want to find the valid ordering of all these n minus two operations. If
Okay.
an operation was not like, suppose there is an answer which doesn't use all of the operations, we can just put any bad operation at the start.
Agreed.
So there is at least one answer which uses all n minus 2 operations.
Okay. At least one answer exists that uses all and minus two operations.
Yes.
The claim
Okay, so
here
now
is
let's go back up.
okay.
So let's consider what happens like let's look at the B in the middle, the second B.
Okay.
So because it is play like there are three operations that affect this index, which is at second, third, or fourth place. Those are the operations which affect this index.
Right.
Because we see a B here, we know that the blue one must be the last operation done. Because if anything else was the last operation, it would be either A or C.
Okay.
The
B
blue one
super
is the last.
agreed.
Yes. So what we do is that we create a graph where we add an edge from green to blue and from white to blue.
A directed edge like this.
Yes. And another directed edge from the white to blue.
Got it.
So what this basically means
And
that in any valid in a valid ordering, the blue must come after green and white.
right.
And then we just toposort the graph and we output the toposorting if it's valid, if a toposort exists,
Got it. And for
because
example,
this
what would have happened?
automatically.
What would have happened if it was like this? Let's say green. We had A in the middle for blue, and then we had yellow.
I don't the three intervals we are considering are including the A, like they are including the index.
Sorry, one
The
second. Let me just draw here. Let's say this was A,
Yes, so let's draw the three intervals again.
green, blue,
And white.
white. So here
Now
the
you can
claim
see
is
here that the white must be the
A.
last interval to pick.
Got it based on this A.
So we will
We
add
can
edge
say
from green and blue.
a directed edge from green and blue. Okay, this makes
And
sense.
then we can output the topo sort of the graph. If
Got
there
it.
is any directed cycle, no answer. And if there is a C at the first place, those conditions obviously.
Cycle no, topo shot and check for corner check
Check
for
for
corner
corner.
elements.
Yes, like I included that in my implementation itself because like there the white thing does not exist, right?
Got it. Like for example, first element cannot be C, last element cannot be A or B.
Yes, second element cannot be C, those conditions.
Got it. Like first element must be A, second element can be
Last
both A
element
and
must
B,
be C.
and A, B, C, some sequence element like this. Last element must be C here, second last can be B or C, and third last can be A, B, or C, and everything else. Okay, yeah, that this makes sense. So we essentially have to check these two index and these two index and then look for topo sort. Okay, this looks probably harder than I'm not sure how many teams would have done it using this. Like 82 teams have solved it right now. So
Hmm.
yeah, what do you think? How many teams would have solved it by this idea?
15 to 20.
Okay, let's
I
see.
expect
Like
a
I
15 to
estimate that,
20.
but I expect like it would be even less.
Okay.
Like I would be surprised if more than 5 teams have used topo sort for this problem.
Actually, a lot of I did this. I think like Jatin also did this. I'm not sure what Nishang did, but like at least Jatin I know did this only.
Okay, and I think my idea was looking at the reverse one.
Yes, looking at the reverse, we can cover that as well. Let's leave out the okay, let's just discuss the necessary condition, and I'll leave the construction part at least.
Okay,
The necessary condition, first of all, the element sequence must start with an A.
okay, like let's look at this is solution two.
Yes, this can
Solution,
this can solve a more harder problem based on this, but we did not make this one harder by forcing this observations.
okay, basically sub array asking L to R that I see
Like
can
we can
potentially be
or
hardware.
counting, we can counting, we can there are
Mm,
lots of solutions.
got it.
We
So
could make a
necessary
matrix
condition.
exponentiation counting problem.
Got it. A
Okay,
first
so
element
first,
must be A, second element
yes,
must be A or B, last element
yes,
must be C, second last
B or
element must
C,
be B or
sure.
C. Yeah.
Now there are some more clear. There are some more things. Whenever you have an A,
Whenever we have
the
A,
next element must not be a C. AC is invalid
okay, AC is invalid.
and BB
This
is
makes
invalid
PB is also invalid. Makes sense
because why you
because
can check that if
whenever we get this A, we would have printed A, B, and C. Then if we
yes,
override
and
here,
whenever you
we
try
would
to make
have
this
got
a C, yes,
overriding here would have made this A and this B. And if we try to
yes,
make
yes,
this C, then we will end up with B or A. Makes sense.
yes, and the second one you can also see similarly is invalid.
Similarly, we can go for B as well. If we try to add B, then we will end up overwriting another character. So are these
Yes,
two the only invalid cases or there's
yes,
any more?
these are the only invalid conditions.
Got it.
In fact, you don't even need the second character and the second last character checks because this covers that.
Right. A after C is not allowed.
And
This
again, A after
character,
C.
okay, but we definitely need first and last character check, right?
Yes, first and last you definitely need to check.
Got it. And I think like the easiest idea which most team would have done over here is
Yes,
like look
is looking
elements
at the
from the last.
operations in reverse and doing any doable operation basically.
reverse and do doable operations. Like the main idea is like if there existed a valid sequence, there would have been some index where you did the last operation, right? And that would
Yes.
have given you ABC.
Yes.
So find such an index.
The general idea basically is that when what we mean by looking at it in reverse is that, see, what we do when we go forward direction, what we do is we overwrite elements, right?
Oh, oh, right. We override question marks with some characters. And if we
Yes,
go in
you
reverse,
overwrite, even if you had an A before, you also override it with the B if now if you got a B, right?
right? Okay.
But what we do
So
when we go in reverse, why is it helpful? It's that now overrides do not happen. If something already has a character, it will not get changed later on.
agreed.
So the operation
So
sequence goes from change this to ABC to change this to ABC only if it's not written already, because it does not, we cannot do overrides in reverse.
okay, so you are suggesting I start with question mark. I decide the place where I would add ABC. For
Except you will
example,
not
here
overwrite anything.
ABC, and then when I'm doing an operation here, I will just write A here. Will not do anything here.
Not do anything. And this is essentially equivalent to looking at the operation sequence in reverse.
Right. The idea is like when you apply, for example, first here ABC, and then you override here ABC, you will end up getting this override. And that's why
Exactly.
when you are trying to do it in reverse, you are not overriding. Yeah,
Not
this makes
overwriting.
sense.
And this is why this makes it easier, because you can just, so when you're not overwriting, it is pretty simple. Like you have to, when you're using an operation, you have to make sure that you will do no other operations with the elements affected by this this operation, right?
Right.
Basically, these are the final operations for all those, and you can keep a set of doable operations in some sense.
Doable operations. And I think my idea was also same. Instead of doing it like this, what I was trying to do was maintain the set of where ABC can exist. So, for example, this is the array, and ABC exists here. I said this was my last operation, and I replaced these three with, for example, I replaced these three values with question marks here. And the
By
idea
the way,
was
I
now
just,
if B and A exist, then I can say like this is a potential
yes,
match
yes.
now.
Yes, so what I was saying is that I just checked the last four ACs on that problem.
Hmm.
All of them are doing neither solution 2, neither solution 3. They are using solution 1, which is the necessary condition, and then constructing.
Okay, that's interesting.
Teams, I guess teams are not that familiar with this approach, or maybe they
Mm,
aren't seeing this approach as viable for some reason.
right. Yeah, this makes same conditions we have seen C after A, B, A, etc. cannot have same necessary. Okay, at least these guys are doing what I was suggesting.
Okay, okay. Yes, this guy has that,
Do
but he
I
has a
see?
lot
No,
bigger.
right.
Not sure why he
No,
has such a long code. All
no,
my codes for this problem were like 20, 30 lines.
yeah, I think that that's where we are. And I think this was the idea for ABC STEM. And I
Yes.
think we ended up discussing all the problems which had more than 10 AC so far.
Yes. Recursion is going a lot faster than expected,
Yeah.
while the
And
others
like
are not.
Yeah, and it's around 1 hour, almost 30 minutes remaining for the teams.
There's another, I guess there's another 800 right now. Some, it is, it
Yeah,
is, hey, I do, Roorkee team is now at second place.
right here I do CP and prefer
And
not to.
CMI finally submitted a time limit exceeded for Max. They have a flow solution.
Okay,
They have a flow solution. I'm not sure why they are using flows, but
okay. Clinic.
did they expect it to pass or something? I'm not sure what.
I think like generally the time complexity of flow people consider it's RNG rather than whatever code book says.
Okay, but
That might be the reason why they ended up with flow.
or maybe they're just running out of ideas and they decided why not try it.
Yeah. Like to put it in some perspective, like the last time when I participated in on-site regionals, like we ended up our codebook contained some heuristic code for clicks. So we just ended up coding it and got an AC using that. And expected solution was probably
Delhi also has
using
eight
some
now.
virtual. Okay.
IIT Delhi just got XOR 123, and both of like not both IIT Delhi and the IIT BHU first team, both of them have Max's fund left.
Okay. And which other teams also potentially? This
But
is
at least there are a
ITW, I
lot
believe.
more solves on these three problems.
And why is their time too high by the way? Like, do they
To
also have some answer and bad memory complexity?
what is this? Which team is this?
IIT Delhi, I believe.
IIT Delhi.
Yes, I
Like
believe
which?
001 is now.
Yes,
It
yes.
should
Zero
be
zero one is
good.
IIT Delhi.
And I believe this was Mithul's team. They have around 3.73 time.
Okay, they are very close to a time limit. Okay, I see. Not sure why. Like in testing, it was most submissions were under 1 second or even
Yeah.
faster, while participants are having a hard time.
Mm-hmm.
Two different teams have just gotten TLEs and cannot fix their issues.
Mm-hmm. I think one we saw was probably n log square and memory, and time was
Yes.
probably even more higher. And even like the indexes, we should probably have a better way to access them. Small value on the higher in dimension. So that was some cache misses there as well.
Okay, I'm not sure. I'm like, if you check 026 team on L XOR 123 solution, which they got TLE in, that I am not sure what it's doing because it is splitting the
Is
bits
this the one?
into two different parts, and like it is. I guess it is bad complexity only because I'm seeing that it's like 2 to the power 10 into n. Okay, so okay, they are doing square root on the bits. Okay, they have n into square root solution or something. Yeah, they have n into square root if you check it. They're splitting the bits into high and low bits.
Oh, okay.
They
The
tried to pass
assumption is
n square root
for,
basically.
for basically for more 2 to the power 8, like the interval should be too low. And
Yes,
for the
yes,
first child rate, manually.
yes. This is a valid TLE at least. This is not a like not our fault.
Yeah.
And they have a runtime error now.
Runtime might be because of memory. No,
Memory
I don't
seems
think
fine.
right. Memory seems fine. Runtime error may be then some out of bound access.
Might be, might. I hope we see 9 soon. Like there are 3 teams on 8. And 9 decides how many teams will get to try the next 2 problems.
Right.
So far, it doesn't look like there will be any more distinct swords.
Mhm. Shurki. Okay, IIT Delhi has jumped to second place again, and IIT BHU is at the top right now. Looks like few people are trying bin packing 009. Who's 009? Okay,
Hey,
Mushroom
wrong.
from IIT Roorkee is trying. Yeah, wrong answers. And
It looks like
0333.
okay. They definitely have some. Okay, they have some greedy, which is wrong. Just
And Distorted Prime Bhubaneswar is also trying this one out.
they tried to random shuffle and do something.
Like the array is already random. Doing random shuffle might not help. Probably they were betting on if we just do random shuffles for the same array multiple
Yes,
times, we
yes,
can get some good parties in it.
yes. Stream will be ending soon, like in 30 minutes, I
Yeah,
guess.
right. Right, yeah. At freeze time, we will end the stream.
So we can discuss one more problem.
Okay, which one do you like? I think recursion might be the best choice here because it has the
Max.
highest AC.
Let's go, Max. I want to do Max is fun. Like,
Okay. Did we read out the problem or not?
I don't think we did.
No, I think we did read it out.
Okay, yes, we did read it out. Yes.
Yeah, so I can take the whiteboard again. Give me 2 minutes. So we have Max's fun too. So, like, do you want me to take any array here?
Let's just take one of the samples, the last sample maybe.
Okay. I will take the full. Okay, last sample. Okay, I will take the full array. 0 1 1 0 2 2.
Okay, so let's consider the first iteration where we have to choose between 0 and 1.
Okay. First
There we are
iteration is
choosing there
only
we are
this
choosing
array.
the 0 and leaving out the 1.
Okay, let's say here we are chosen 0.
Okay. In the second one, we can then choose the 1 and then leave out the 0 to get a bigger answer. And the last
Okay,
one, we are forced to choose 2. It doesn't matter really.
right,
So final max, we get 3.
right.
So first of all, the first idea in such a problem would be, okay, there I have pairs AI and BI. So let's consider the graph which is drawn by let's consider the graph found by adding an edge between AI and BI.
Okay. So basically, instead of looking at two different array, consider it as a graph where edges are given to you using two different array.
Yes, yes. And you basically
So,
your operation basic
so this would be the first array, this would be the second array,
and
and
then 2
this
has
would
a
be the
self
third.
edge.
Right.
Yes. So here you can basically see that the graph will have a lot of components, right?
Right.
And an edge basically means that you can either choose
Either choose one of the
edge means that you choose either of the ends. Either choose one of the ends, right?
of the
Either
and
of the ends.
right.
So what is the condition under which suppose we cannot choose all of the things in a component? Let's consider let's give you another example. Let's give an example. 0 has an edge with 1,
Okay.
then 0 has an edge with 2, 1 has an edge with 3. You can check that it's actually impossible to choose all of the nodes in on this component because there are 3 edges and there are 4 nodes.
Right. But
Okay. But what if we add one extra edge to this component? Let's add it anywhere. Just let's say 0 to 3.
I will probably add between one and two.
Okay, let's add it between 1 and 2. So now what we do is basically we just see there is a cycle in the graph, right?
Right.
Let's remove the non-cycle nodes. Let's remove 3 and the edge connecting 1 and 3.
Okay.
Because we can
So the
choose
idea is
3
that
as the
okay. The idea is for this edge, let's
we
choose
choose
three,
3.
and
Yes.
now let's forget about it and focus on this
Now we
cycle
are
only.
now we are removed all non-cycle edges and we are only down to the cycle, and then we can just go in cyclic order, clockwise or anti-clockwise order.
Okay. So the idea is for this zero, for this edge you pick this zero, for this edge you
Yes,
pick two, for this edge you pick one. Okay, this makes
exactly.
sense.
And you get all of the nodes in the component, therefore like max will be greater than like max, you will have all of these distinct values in the array if cycle
Values in
exists.
this component
If cycle exists,
if cycle exists. If cycle exists.
we can actually consider the converse now. Suppose a cycle does not exist and the graph is a tree, then what can we do? Cycle not existing means that the graph must be a tree, right?
Right. Do you want me to again take some notes here?
Yeah, sure, we can just take the same example without the extra
Okay.
edge.
0, 2, 1, and 3 here.
So
Or
what
probably
we
I
want
will
to
draw it
ideally,
here.
sure,
Let's draw 3 here.
yes, that will
Let's
be
draw
easier.
2 here.
Yes. So what the idea here is that we want to see, since we want to maximize the max, if we leave out
Mhm.
0, the max will be 0. If we leave out 1, the max has to be less than equal to 1. Since we want the
Right.
maximum max, we have to leave out a big number, right? And we have to take
Right.
all of the small numbers.
Okay. So what do
So
you
what
suggest here?
we want to ideally leave out 3.
Okay.
Ideally, we
So
want to leave out 3. Is it possible?
okay.
Now the question is it possible? And the answer is yes, it is possible. You can just direct every edge away from 3.
Okay.
Direct edges away
Or,
from 3.
or what I was saying was root the tree at the
Yes,
maximum
root
number.
the tree at 3 and then direct edges from parent to child.
Got it. So this has directs to 2. This has directs to 1. This has basically direction means for this has choose 1. Or basically the index where 0 and 1 appears, choose 1. The index
Yes,
where
the
3
index
and 0 appears, choose 0. The index where
and
3 and 2
index.
appears, choose 2. So you will end up
Yes,
taking 0, 1, and 2 here.
yes, and this is the best we can do because there are n minus 1 edges and there are n things to choose. So this is literally the
Good.
best we can do.
Got it.
So after this,
So,
the like this solves the array for a fixed. Like we can now solve the array for a fixed array, and for a like the more difficult array, then like what I mean is for prefix operations, we need to maintain the components and the cycles and everything basically. That we can do
Mm,
with the union find data structure, UFDS or DSU, whatever you want to call it. By the way, update, IIT
Maintain
Delhi have 9.
PSU
Mridul's
plus.
team has 9. Oh, two teams have 9. Okay. Roorkee
Okay.
team and IIT Delhi both have 9. So maybe we
Did they
see a solve
solve?
on the. Maybe there is a
Okay.
possibility of a solve.
Okay. So
I
did
really
they
hope
solve any
one.
new problem or just the existing
No, no,
problem?
no. Just solving the solved ones already.
Okay, on the spectrum.
And hey, hey, I
And
do CP.
the discipline. Got it.
And prefer. You can actually check that the funny thing is that 1, 2, 3 are all next to each other, like 0, 0, 1, 0, 0. They are ranked by like the team IDs were this time given by rank in the prelims, I think.
Got it. Nearby here.
And 0, 0, 4 is not far behind. That is also CMI team. They are at 8th rank.
Got it. So I would be interested in knowing what CMI is doing right now.
CMI had a flow solution to the Maxis Fun problem, like which we are discussing right now.
Got it. And did
After
they
that,
try
I'm not
any
sure.
more problem? I can probably just check.
Anyways, other than that, what in the problem basically after that it's pretty standard, like maintaining components with DSU or whatever.
Okay.
Don't have anything. They are for 2 hours they are stuck basically.
Mhm. But they, I believe, have already qualified for the World Finals. So
Yes,
the
yes. So
result
it's
here.
not a issue. At least we didn't have a winner with less than 9 because that would be
Mm,
sad.
mm. We had 9 problems last year. Yeah, I
Near we
think.
could You made it too easy. Like you should have made at least half the set unsolved.
Mhm.
Barely missed out 4 by 9.
Mm, yeah. Okay, with rank 8 we have Varanasi. Prefer not to say. IT means
Anyway, it seems like Recursion and Maxis Fun and XOR 1 to 3 are picking up solves. So maybe they will have 10 to 20. Maybe Recursion might even have 25, 30 at the end, I guess.
yeah. I think like once you start seeing SEs here, like teams start trying out.
Yes, yes. And so now the question is whether bin packing and easy counting get solves.
Right, at least Midul will
And
have
perfect tour.
around 80 minutes to try out something here.
Yes, it one of them is definitely like one is doable by some teams.
Got it. Which one do you think would be solvable among the FK first?
I think easy counting might have a better chance of being solved.
Easy count. Okay. And at least I think Midul might want to
Because
try on easy counting
I
rather
think
than
bin
bin
packing
picking.
is the objective. I think objectively, I would say bin packing is the easier problem, but easy counting is more usual in some sense. Like it is more
Mm,
standard, like combinatorics, like you're most used to the ideas, while bin packing is like less types of that problem have appeared in recent times at least.
Got it.
When was the last time you saw a random input problem?
When was the last time random input problem?
Yes.
Okay.
I remember one very old edu round which had a D and the problem name was problem with random tests, and that had a binary string in input, and the idea was that within the first 20 or so indices, you will always get a 0 or 1. Like you will get both the things.
Okay, I remember that one actually. I think that was something Satyam also solved. No, I think
That is like 2 years old at least, I think.
yeah. Okay, no, I remember the wrong problem where the solution was slow and they were asking choose a set of numbers and the result is bitwise and plus something or something like that was there. Okay, yeah, like when was the last time I saw a random input problem? I don't remember. If I can count who I challenges, then those do have random.
Yes, who
But who I
those okay. Like
yeah,
normal
but if
competitive programming.
normal competitive programming, I think I would have seen some problem on at coder where I
Okay.
think there is a and okay, yeah, I remember the one. There was one problem in Snackdown World Finals.
Okay.
There they were expecting some knapsack and tourist code was to just randomly permutate the array and then he was making some observations like similar to what we need here. He
Yes, but like
they
was
have
the
to they
input
have to
like
no input
I've
was
seen a
not
lot of
random.
problems. I've seen a like what I mean is that I've seen a lot of problems using using randomized algorithms, but I haven't seen like recent times random input problems are not that common.
Yeah, unless you include top coder. Like top coder has a different like they have a old stack, so they have problems with giving array size more than 500 or
Oh
something like that.
yes, yes.
For 500 or 5000, so they just include initial values and then give you as the random number generator.
Okay.
And yeah, I think I remember now one educational round also had where they wanted to give seven numbers as input to reduce
Yes,
the time
and they asked you to
complexity.
generate them using
Right.
X and Y. Yes, I remember that as well.
Okay, people are asking who would be in your team next year for the ICPC.
I don't know yet.
Okay. Got it.
Middle's team had three solves pretty fast. They were at six at some time, and then they kind of jumped to nine in like 30 minutes or so. Let me just check what
So
was the difference. They
yeah,
solved
I can
I
open.
10. They
Their
solved
team name
yes,
is 001, right?
yes. In fact, it
39,
was 29 minutes. Within 29 minutes, they have three different ACs.
4 in fact.
AP sub is
When
before.
okay, just said okay. From 39 within 30 minutes they solve three problems. Yeah.
Yes. I guess like they all three of them were working on a different problem and they just were giving each other coding time at that time.
Right. Yeah, like that's what I told. Like problems remaining problems are more like code is small. So it's possible ki if
I think
you
I'm
solve it on
sure like
properly, you can
not it's small enough, I guess, bin packing.
not, yeah, for these three it's definitely not small, but for
No,
these
no, no.
three at
Easy
least.
counting is pretty small.
Okay.
Like it's a counting problem. How big would it be? Counting problems usually have very small codes only.
No, yeah, I remember we were discussing with Jatin once, and he said the reason, and I think Satyam has also said the same. He prefers setting counting problems is because generating test cases is easy.
Yes, generating test case is very easy. Like you just 10 minutes, 15 minutes and you're done. You don't
Hmm.
have to think about anything.
I think 14 more minutes for the stream, and this rank list was probably updated 14 15 minutes ago, and this is current rank list. So NIT Trichy has also solved 8 problems. NIT Trichy is doing pretty good, by the way.
Yes,
Okay, people
yes.
are asking, what do you think? What are the chances for IIT BHU to be at top?
I think that Delhi will be top.
Yeah. Okay, let's calculate it. Let's assume 4 hour penalty here. So
Oh
if
wait,
IIT
they
BHU,
have oh right, they have better. Yes, they have better penalty right now.
right.
So they will be
So
like okay,
we can just check
penalty
it.
wise they will definitely beat. Penalty wise they will beat. I think they will get it eventually. Like Maxis one, they should not take a lot of time, so they will get it eventually. If they
No,
do
like
not get any
there are,
WAs, then
yeah, if they do not get WS, then BHU would be at top. But if they
yes.
get one more WA,
No,
then
this
they
is zero
might
draw.
drop.
This is wrong name. This is 022. You have to go for 002. If they do not get any WAs, then they will be first for now. If no other problem gets solved,
Right. And
then
looks
last
like they
solve was
are
also
pretty
1 hour
good
ago.
in, yeah. So I think until 20th minute in the freeze time, if they end up solving without any penalty, they would be at top. So they essentially have right
Yes,
now around 30 more minutes to solve one more problem and get an AC and be at top.
and we are still hoping there's one
Mm,
more solve by Delhi
I think, right.
or Roorkee.
Yeah. Like I think Delhi can probably solve this one out
Yes,
and
I think they will pick
ignore
up
the
easy counting problem only because Mridul is like he is quite good with counting, I guess.
right.
And the problem name says easy counting, so it must be easy only.
For them, not. Yeah. Mhm. Okay, Sren. I think Sren is planning to drop. And thanks a lot, Sren, for joining us today.
Thank you
It
for
was
having me.
fun discussing solutions with you.
Yes,
And yeah,
same.
yeah.
Okay,
Thanks
bye
a lot.
then.
Bye. Looks like there are more ACs on these problems. I think rank list would be frozen in 10 minutes. So I will end up ending the stream. If anyone wants to know probably the rank of their favorite team before we call it a day, I can just do one round of rank list check from the live rank list if Excel sheet is not updating. Just let me know which college you would like to see. NIT Trichy. Okay, Trichy status right now is they are at rank 4 with 8 ACs. And yeah, and I think I might be also interested in checking if they have made any wrong submissions. 427, I believe this is NIT Trichy. And they do not have any new submission right now. 2, 3, 4, 5, 6, 7, 8. Yeah, like they just recently solved XOR 1 to 3. So they might want to try for recursion now or Maxis one. Maxis one would be the next problem I think they will try out. Okay, IIT BHU is the next one. Okay, BHU status is 3, 13, 42, 8, 6, and 5. Rank 3 is prefer not to say, to be called and placeholder. And if they end up solving Maxis fun within next 30 minutes, they would be the first in. IIT Delhi. So like they have team at rank 1, 9, and 20. First is on the spectrum, which has solved 9. Then they have touristers, which has solved 6. And they have solved Mangal Daku, which they have solved 6 here. Then we have Hyderabad. Hyderabad teams are at rank 5 and 10. One team has solved 7 problems, one team has solved 6 problems. 100 Sage has solved 7, and ETH has solved 10 problems. Then Triple IT Hyderabad is also the ask. They are at rank 15 and 40. Lazy 3 has solved 6, and Logged In has solved 5. Mhm. IET Lucknow. IET Lucknow is at rank 53. The team name is Alien X. They have solved 5 problems. Kharagpur is also an ask. Kharagpur is at rank 32 and 39. Both the teams have solved 5 problems. W on test case 2 and error not found. I think for BHA, last we checked, prefer not to say, did not had a WA yet, which was 5 minutes ago. IIT Mandi again. They are at rank 91. 3 solves. Binary Beast is the team name. And then Triple IT Surat is the ask. Rank 74, 4 aces. SRJ Programmers team name. MRU. Probably you can provide the full name we need for MRU. Then Rudkey is the ask. Rudkey is at rank 2. Hey, hey, I do CP 9 solves. Case testers rank 11, 6 solved. Mushroom 6 solved, rank 17. And Bite Size Dreamer 5 solved, rank 51. I think Hyderabad, I just recently checked. DTU is the one. DTU is at rank 42 and 45, 5 solved each. First team is RRR, and the next team is Bit Manipulators. Triple IT Ranchi. Rank 35, 5 solved TLE pre-test 11. LNMIT. Is like, probably, can you say like how do I search for LNMIT? Triple IT Hyderabad, Mandi VIT Chennai. VIT Chennai first team has solved six problem boa constructors and ternary rank 64 5 faces so far. Pandit Deendayal Gandhinagar University. Deendayal Energy University Gandhinagar. They have solved six problem rank 14 right now. Zorius is the team name. Madras. Rank 8 7 aces so far. Team name is the Blasters. Manav Rachna University. Rank 81 4 solves right now. Is it so team name? Naya Raipur. Retired. Retired is 5 solved right now. Rank 46. NSUT. NSUT West Campus. Rank 75. Team name is Code Pro. Roudkela. NIT Roudkela. Rank 79. 4 solves binary bug. Rank 80. Ternary 24. Like nearby each other. Both of them are solved 4 problems. They are solved much faster, but they have penalties here. And I think Valchand rank 27 6 aces. Lazy Coders is the team name. LNM Jaipur. Rank 41 6 aces. Team name is Bazinga. Scalar School of Tech. I think NSUT I have already checked. Rank 82 4 solves right now. Hargure is the team name. And I think I have pretty much covered every team as well. And just 18 more seconds for rank list freeze as well. Yes, NSUT West Campus, I think I have seen once. You can probably rewind once and check. And I think the freeze time has started, so probably I will not reveal more aces then. And I think Hyderabad also was checked, both IIT and Triple IT. And I think this is now close to our stream end time. We have less than 1 hour left, and we generally don't reveal the rank list for last 1 hour. So thanks a lot, everyone, for joining with us today. It was fun having you all. I think we may have one more stream for Asia West as well. And thanks a lot for joining us today. I think that was all we had for today. We will have more, so stay tuned. Thanks a lot for joining.